We are going to be looking at quadratic functions, these funky U-shaped curves. They're called parabolas. We're going to look at them in a couple different forms. We're going to start with what I think is the easier of the two forms, which is vertex form, where we actually get told what this vertex is ahead. And we'll explain what a vertex is first. My vertex is where my graph changes direction. In other words, if it's going down, and then it starts to go up, that point where it changes is called my vertex. Or if it was going up, and then all of a sudden it starts going down, that's where it is. It's almost like it's the middle of my graph. So we're going to start a little abstract here. I know, lots of variables. We're going to get numbers in for everything here in just a minute. But I always can find my vertex in vertex form by just writing down whatever these two numbers happen to be. And we'll talk about what if there's a number in one place and not the other. What if there's numbers in both? We'll figure that out. These other values that are here, the x is going to be itself, but this a value, what does this mean? This is what I multiply the y value by. Because anytime when we're graphing, we have x and y values. That's how we figure out where the points are going to be. So if there's a number there in front of my parentheses or in front of my x squared, that tells me what I'm going to times the y values by. If it's positive, this number in front, my parabola opens up. It looks sort of like the one right below. It looks sort of like a U, or maybe a V, if you wanted to think about it that way. But if that's a negative number that ends up in front, and we'll get to see a couple of those too, then it's going to open down and it's going to look more like a hill. Okay, or maybe an N if you don't put your little curve on the end there. Those are the basic things that we're going to be working with. More of what those things mean, even more than the actual graphing part of it. So, everything though, I can double or triple star this. Everything with graphing parabolas comes from this thing called the parent graph, or my base graph. Okay, f of x, see, I'm not really worried about f of x. Let's put this in a term we like a little better. Let's call this y. I think that'll make more sense. We're used to xy charts, so that's how we're going to do this. So y equals x squared, and this is what a picture of it looks like. So when I'm doing these, it's always nice if I can figure out where my vertex is right away. So if I just look at the picture, we marked it before because again, it's where it stops going down and starts going up. My vertex here happens to be at 0, 0. And that's not a fluke because my vertex, each time that I do this, is going to be found right in the middle of my graph, or if I do a chart, right in the middle of my chart. You're like, now, could I type this in the calculator? Could I get my points for a chart that way if I wanted to? Let's look. So if I went in and hit x squared and hit graph, okay, looks like the same picture, so that's not a big deal. And if I went charting, okay, thank you. And if I went to my chart, I would also notice there's my 0, 1, and 4 for my y's with those values. But notice the numbers are the same on the top and the bottom. It's called symmetry. That's how I can find my vertex if I wasn't sure. Once you see the numbers on top and the numbers on the bottom just separating out, 1, 1, 4, 4, 9, 9, that's what the definition of a parabola is going to be. So that's how we would figure that out. So when we're doing these, we'd do those and then we'd plot my other points. So if I was looking for values like I just had up on my chart before, I'd plot at negative 1, 1, 1, 1, and then at 2, 4, and negative 2, 4. And those are the same 5 points I'd start with every time. So if I kind of get used to seeing these numbers, it's going to make life pretty simple. But is everything always just going to stay in the same spot? Of course not. Sometimes things are going to move around a bit. So here's when we start talking a little bit about movements these can make, or shifts. The shifts are going to be those same values that we talked about for our vertex before. My h value moves my parabola either left or right. Now, unfortunately, though, my h value is kind of a liar. I go, liar? Didn't know math terms could be liars and tell the truth. Because if I would think about it, normally you'd think if it's left, that'd be negative. Because left, you're moving negative, it's the negative values. But it's exactly the opposite of that. My left, if it's a positive h, I'm going to move to the left. If it's minus h, I'm going to move to the right. You're like, well, why is that? Because this minus changes the sign of my number. And it's going to change the x value of my vertex. So if I went right 4, that's going to move right 4. Okay, if this moves, I don't know, left 3, it's going to move my x value left 3, which makes me less needy of the calculator, we'll just say. The value on the end is just hanging out by itself, not in the parentheses. Moves my parabola up or down. Now, that's not a liar. That's what you would think. Down, you think negative. Up, you think positive. So it works out pretty well doing that. So those are the things that can happen to my graph. But again, they all come back to my original values, these guys. If you're going to remember one main thing about this whole lesson, okay, let it be getting used to that. And for now, again, you've got the chart there. You'll be able to use it. So for these examples we do, we're going to draw up this parent graph. So we're always going to start with this, and then we're going to work from that. So let's see. Can I squeeze my graph and my chart in the same place? I think we're going to make it. So when I do my parent graph, okay, I'm just going to do that in regular. I'm just going to do the dots for it. So I'm going to take these points and I'm going to plot them again. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Now, if you didn't notice before, these are all just my x values, numbers that I squared. 2 squared is 4. 0 squared is 0. 1 squared is 1. I always want to have those at least 3 and preferably 5 points to work with. Now notice I'm not connecting them because I'm going to look at those dots and now I'm going to look at them and say, okay, I'm supposed to have a shift going on here. So this minus 4 that's in the parentheses, what direction am I going to be going? In the parentheses, it's h. So this minus 4, am I going to be going left or right? I'm going to be going right. So my shift is right 4. And what does that mean? That means every one of these dots that are here, I'm going to move them right 4. 1, 2, 3, 4. And make my new dot. 1, 2, 3, 4. 1, 2, 3, 4. Start here. 1, 2, 3, 4. And 1, 2, 3. Oh, it's right on that dot. Okay. And connect the dots because this is the actual graph. Y equals x minus 4 quantity squared. Now here's what I want you to notice though. Let's go looking for the vertex. And then we're going to get this part filled in because I want you to see how this works. So my graph's going down, down, down. Then it hits right here and starts going back up. What point is that? Close. 4, 0. You're like, okay, so what's that mean? Well, when I did all of these, like we set up here, this h value moving right changed the value of my vertex. I plus 4 to each of these. So what I actually did was, negative 2 plus 4 is 2. Negative 1 plus 4, and I won't make you do this on all of these. 0 plus 4 is 4. 1 plus 4 is 5. 2 plus 4 is 6. But my y values didn't change at all. And this is why it's so important to understand that base graph, because these are the points I just plotted. 2, 4, there it is. 3, 1. 4, 0. 5, 1, and 6, 4. Again, can I do it on the calculator? Sure. If I wanted to graph this on the calculator, I could put in my parentheses, do my x minus 4 squared. Look at the picture. I notice it shifted to the right, just like mine did. I can look at the chart. Now I notice here if I go to 0, my numbers aren't the same above and below, so I must not be to the middle yet. So I keep going until I see, oops, now I am. 149, 149. And look what's right in the middle, 4, 0, my vertex. And that'll always be the case. Whenever you have a chart, bless you, whatever value's in the middle, that's what that would be. But again, I think it's easier, rather than hitting that and hitting chart and looking all over for the vertex, just to take my initial graph, my parent graph, this guy, and then just shift the points. It makes life pretty simple. And you'll also notice it opened up because I notice on here that it wasn't negative. And we're just going to do this for several of these to get used to it. Now again, I want to keep reminding myself, my parent graph, 0, 0, and then I go up to 1 on each side of it, and then I go up to 4 on each side of it. Those are my original 5 dots, my parent dots that I can use on every one of these. And then if I know the shift, I just shift them, I'm done. So here's the question this time. If we got to flip back to the front page, that's okay. This plus 2, what direction is that telling me I'm going to be shifting everything? Close. Because normally you're right, it said, oh, plus is left. But remember, the plus to be left is if it's in the parentheses. Do I have any parentheses this time? I don't. So it's a k value, and a plus k value means I go up. So I come back over and I say, okay, my shift is going to be up 2. So again, every one of these points, I just go up 2. And connect the dots. I always like to go looking for my vertex. I see my change of direction is right here at 0, 1, 2. But like we mentioned on the front, any shifts up and down change my y value. So all of those initial y values that I normally have, it's 0 and 1 and 4, I'm going to add 2 to all of them. And then we're going to see kind of where this comes from. So I should have y values at all of these points. Now let's see if we did this right. Do I have a point at negative 2, 6? I do. Do I have a point at negative 1, 3? I do. Do I have a point at 0, 2? I do. It's in the middle of my chart, and there's my vertex. Might have to see a pattern developing here. 1, 3, absolutely. And 2, 6, dead on. Nailed it. So whether I want to just make the chart and understand and then plot the points, or just plot them off of there, I'm good, I'm ready to go. So I can see how that affects my vertex. Now what happens if we start doing 2 things at once? Oh dear. So example 3. Still going to put my parent graph in. 0, 0. Everybody can remember 0, 0. And then I do 1 on each side of that, and then 4. It's just my first perfect squares. Get those parent points in. Now this time I got 2 shifts working. What are my 2 shifts going to be? Then we'll play this one on the calculator too. What's that plus 1 in the parentheses telling me? What direction am I going to be going? Left 1. And then that -3 on the outside tells me I'm going to go down 3. So I got 2 things I'm doing with each point now. Initial point, I go left 1, and I go down 3. I go left 1, down 3. Left 1, down 3. Left 1, down 3. Left 1, down 3, which hits me on that dot again. And I get my parabola drawn in. I notice my place where it changes value is right here at -1, -3. And you're like, hey, I'm noticing something here. Like, our vertex initially was at 0, 0. Now, on number 2, we went up 2, and the vertex was at 0, 2. It just moved up. Yes. And then, like on example 3, we moved left and down. Well, if I start at 0, 0 and I go left, that's -1. If I go down 3, it's a -3. I don't even need the picture to get the vertex. Right. If I understand the directions of the shifts from this, I can just mentally think of them. Or I can just say it's the opposite of this value, and I keep that one just the way it is. If I wanted to look at the chart, my left number would mean I'd -1 to each of these, and my down 3 would mean I'd -3 to each of my normal, which I didn't write in here, y values. So I look at that and I say, okay, if I -1 from each of these, -2 minus 1, so this would be -3. -1 minus 1 is -2. -1, 0, and 1. And I notice my points where they had x, y's, -3, -2, -1, 0, and 1. Okay, that makes sense. And then my down 3s, I'm going to -3 from each of these. So 1, -2, -3. There's my vertex. -2 and 1. And I can check all my points, and I see they're all the same. Now, do I have to do this chart thing each time? No. But again, if you're not as visual, if you're more, I like adding and subtracting the numbers instead of doing these shifts, it's a way you can do it. It's a way you can come up with the values. So on this last one, with this type, we are just going to draw the graph. I'm not going to worry about this time. So I take a peek and I say, okay, parent graph. 0s, 1s, and 4s. All right. What are my shifts this time? What's that -3 in the parentheses stand for? So we might even be able to use example 3 to help us, because it looks like it's the opposite, basically, of what we're doing in example 3. Right 3. And up 4. So I'm going to take each of those points. I'm going to go right 3 and up 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Just keep. And then I do the same thing to figure out my vertex. If I start at 0 and I go right 3, that's going to be 3. If I start at y = 0 and go up 4, that's at 4. Let's see if I'm right. 1, 2, 3, 1, 2, 3, 4. There's my vertex. I'm good. And I can figure out my vertex just from looking at the equation. So, hey, it's nice to be able to have that as an option. There's only one other thing we're basically going to be looking at when we're dealing with vertex form. Sometimes we don't want to have to necessarily deal with a picture every time. I mean, it's nice. I can draw one. But what if what if I don't feel like drawing a picture? What if I want the equation, but all they give me is the vertex or the shifts? Okay, that's not a problem. All I'm going to be doing is plugging values in from the information that they give me. So for instance here, if they give me the vertex, they're giving me the h and the k value. Okay, I know we think of it as x and y, but in this case, it'll make it easier for us to get our equation because now y equals, I don't have any shifts, so if I don't see one, I'm just going to make my a equal 1 if I don't see something that tells me otherwise. X minus, that first point's my h, so there's a 3, plus, and there's my k value, 1. I have made an equation in vertex form. I don't have to have the 1 there because we assume it, but if you put it there, that works out okay. And that's all I'm going to do on these. If I have my h and k, y equals, I don't see anything about an a value, so I'm just going to leave it out this time. So I've got x minus h squared. I could put plus -5, but that might get confusing. So I'm just going to put minus 5. Or in this case, since there is no h, x minus 0 is just x, I could just write it this way. But both of them are perfectly fine, acceptable ways to have that written, to make that go a little bit better. What if they only give me the shifts? Okay, I can make that work. So I'm like, right 4. Let's go back for a second here. Right 4. Back to the front. So right means it's going to be a minus in the parentheses. Okay. So if right means minus, that means my h is 4 and my k is -3, because I remember it's x and it's minus if I want to go right, and it's minus if I want to go down. And I just got to get used to seeing those a little bit. What if I'm only given one shift? Okay. Left is supposed to be plus in there. So I'm going to put plus. If I don't have an up or down, can I put +0 at the end? Sure. Do I have to? No. I don't have to. But that just allows us some more flexibility in what's going on. And then my last one. Well, what if they just give me a graph? They don't give me any points, they don't give me any shifts, they don't give me nothing. The hint here is, where is the vertex? Where does it change from going up to opening down? Right here. So at -2, 4, which would be my h and k. But here's the difference on this one. On this one, notice it's opening down. So if it opens down, my a value here would be -1 instead of 1. So I'm going to put a -1 in front of this. But then, since I have this value, I can just copy. So if my h value is negative, x minus -2, we'll fix that in a minute, plus 4. Because again, that negative isn't this one. That's part of my formula. What happens when I minus a negative, though? It becomes positive. So my equation here would be negative 1 x plus 2 squared plus 4. Because if I were to double check this, which I am going to do because I'm curious if I did this right, if I go to y equals and I type this in, I should get a graph that looks pretty similar to the one that I just was looking at. And there it is. It's opening down. My vertex, if I go find it here, my vertex is at negative 2, 4. Check it out. 3, 0, negative 5, 3, 0, negative 5. I got symmetry. I did this right. So the calculator is a good way to double check to see if you're doing things correctly. I wouldn't do it for everything, though. So here's your job that goes along with it. Let me grab one of these sheets here real quick. Your job that goes with, and this is getting us ready for the next homework check, which I believe, let me check myself. We're at homework check 11, number 1. For 1 through 10, all you're going to do is say if the shift is left, right, up, down, whatever it happens to be. But I do want you to add one thing to this for me. I would please also ask that you name the vertex. So we can just get into the habit of that, because if we can get a vertex, it's easy to make graphs from there after that. And then the ones where there's graphing grids, I want you to actually graph it out using your parent graph. And if they don't give you a good spot for your parent graph, you're like, hey, for instance, you get down to number 11, and you say, okay, I want to graph this. I notice there's a plus here, so I know that's left. And I see this plus outside, so I know that's up. But Harty, when I go to put the parent graph in, there's nothing to the right. It's all this negative stuff. What am I supposed to do? Well, here's what I would do. I'm just going to give myself a little bit more room here to the right. I'll get my 1, 2, 3, 4 in. Because then I'm like, okay, I like my parent graph. I'm going to work with it. I'm going to go ahead and get those 5 dots in. And then I'm going to move them, just like I've been moving them all the other times. I'm going to move them left 4, and up 1, and left 4, and up 1. Left 4, and up 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. They connect the dots, and then I can get my vertex either from my graph, negative 4, 1, or I can remember, oh yeah, to get the vertex from the equation, it's just the opposite of this, and then whatever's available there on the end. So that's how we'd end up working and dealing with those, at least how I'd tackle them right now. But again, keep the note sheet out and available, especially for your parent graph if you need to, with those initial points, and then just move them from there. That's all we're going to be doing. We're going to be playing with some more of this tomorrow and some more figuring out the equations thing, but you don't want to take everything on at once. So get those in. Let me hit one.